Example 5.5. A solenoid has a core of material with the relative permeability 400. The windings of the solenoid are insulated from the core and carry a current of 2 ampere. If the number of turns is 1000 per meter, calculate H, M, B and magnetizing current IM. First, we will realize the given values. Mu R value, what is mu R? That is given as 400, that is relative permeability. Current in the coil, that is 2 ampere. Turns per unit length, that is small n, right? Total turns is 1000. Turns per unit meter, that is 1000 turns per meter. N value is 1000. Okay, we'll start one by one. Magnetic field intensity, H, correct? H is asked. What is the formula for H? H equal to N into I. What is N? Number of turns per length. So H equal to 1000 into 2, 2000 ampere per meter. Or 2 into 10 to the power minus 3 ampere per meter. Okay, second one is B. Second one is M. What is M? H is magnetic field. M is magnetization. Magnetization equal to mu R minus 1 into H. Mu R is 400. H value we got it as 2000. If you simplify, you are getting 7.98 into 10 to the power 5 ampere per meter. We'll go for the third part. What is magnetic field? Magnetic field equal to mu 0 mu R into H. Mu 0 is 4 pi into 10 to the power minus 7. Mu R is given as 400. H value is 2000. If you simplify nearly, you are getting 1 Tesla or 1.005. You can approximate it to 1 Tesla. We'll go to the last part now. The magnetizing field current IM B equal to mu 0 N into I plus IM. IM is asked in the question. Current in the material. B value is 1. This is taken as 1. Mu 0, 4 pi into 10 to the power minus 7. N equal to number of turns per meter 1000 into current. We got it given as 2 and IM is to be calculated. So 1 equal to 4 pi 10 to the power plus 3 minus 7. It becomes minus 4. 2 into IM. 2 into IM equal to 1 divided by 4 pi into 10 to the power minus 4. So if you bring 10 to the power minus 4 to numerator, it becomes 10 to the power 4 divided by 4 pi. 4 pi value is 12.57. If we simplify, you are getting 795.2. Therefore, IM equal to 793.8 ampere.